We're on page 5, and this is still example 1, part C. Knowing that there's a half gallon left in the gas tank when the low fuel light comes on, will the mom make it to the nearest gas station? Explain why or why not. So she's got a half gallon left in the tank, and if we look up here, we know that she gets 28 miles for each gallon of gas. So she can go 28 miles if she's got a gallon of gas, but she only has a half gallon of gas. So 28 miles for 1 gallon, but she's only got a half gallon. So that means she's only going to be able to go 14 miles. And looking back up here where the gas station was, gas station is 26 miles away. So we would have to say, nope, she won't make it to the gas station 26 miles away because she only has enough to get her 14 miles. And then moving on to letter D. Letter D says use the equation found in part B. That was this one right here. Using that equation, determine how far the mother can travel on 18 gallons of gas. It says to solve the problem in 2 ways. One's using the constant proportionality, which is going to be this way, and another using an equation. So this brings in math practice number 4 that we talk about, that a lot of times there's more than one way to solve a problem. So using the constant proportionality, we know that that is 28, and that 28 means 28 miles for each gallon of gas, and she has 18 gallons of gas. So you would be able to take the 28 miles for 1 gallon, multiply it by 18, and 28 times 18 comes out to 504. So she would be able to go 504 miles on 18 gallons of gas. Now using the equation, we're using this equation right here, m equals 28g, and this is just starting to push you a little further into the algebra exploration. So we know there's 2 variables here. This one stands for miles and this one stands for gallons. If you look back in the problem, the one that we know is 18 gallons. So which one would you replace with 18? And that would be the G. So you would have M, the miles, is equal to 28 times 18, because that's how many gallons. And as you can see, that's the exact same calculation we were doing over here. This just has more of a algebra look to it. So M is still going to be 504 miles. Moving on to letter E. E says using constant proportionality, which we know up here was 28, and then using the equation, determine how many gallons of gas would be needed if you were going to go 750 miles. So again, we know that you can go 28 miles on a gallon of gas, but we want to go 750. So we're trying to see how many of those 28s would fit in 750, and that would be a division problem. So you take that 750, split that up by each little gallon, which would be 28 miles, and when you divide this, something very interesting happens. Not everything in life comes out to a pretty whole number. So this comes out to a decimal that it doesn't even appear to have a repeating pattern to it. So I'm going to round. And when we're talking about gallons of gas, it makes more sense to talk about like just whole gallons of gas. So I'm going to round this to the nearest whole number, which would be 27. So this is my approximately sign. Not mine. It's a real math symbol. This means approximately 27 gallons. And then using the equation method, we're using that same equation we had used before, that miles are equal to 28 times the gallons. And this time, which one do we know? Do we know the miles or do we know the gallons? This time we know miles. So you're going to take 750, put it in place of the miles, and we have 28G. And this would have been a type of an equation that you would have solved last year in 7th grade. This means multiplication right here, so you're trying to figure out 28 times what number would be equal to 750, and the inverse operation of multiplication is division. So you would be doing 750 divided by that 28, and that does give us that same very strange decimal that we were just dealing with. So this time we'd say that the gallons are approximately 27 gallons. So G is approximately 27 gallons, which was the same thing we had before.